Alright, moving on to number 11. We've got the natural log of e to the at squared minus b. Bearing in mind, a and t are just constants. Now, since the base of natural log is e, and you're taking the natural log of e, so since you're taking the log in base e of e, the log in base e of e cancel out, and honestly, you're just left with at squared minus b. So y prime of t in this case is the derivative of a number times t squared, which we would bring 2 down, the number t power 1 less, and the derivative of b is just 0. So this would be your answer. Alright, f of x. We've got log in base 2 of root sine of x. Okay, I'm going to rewrite this as log in base 2 of sine of x to the 1/2 power, which allows me to take that 1/2 power, bump it down in front of the log, and it's 1/2 of log in base 2 of sine of x. Alright, taking the derivative of this equation, and what we're using here is d dx of log in base a of u is u prime over u ln of a. So we have that extra 1/2 up front times derivative of log in base 2 of sine x is u prime. If this is u, derivative of sine is cosine of x over u, that's sine of x, ln of my base is 2. Alright, cosine of x over sine of x is really just the cotangent of x. And here on the bottom we have 2 ln of 2. Just one more trick that might happen, and like I said, on the multiple choice questions, this 2, normally we bring powers down and put them in front of logs. We can also bump them back up. So really, this could be the same thing as the cotangent of x over the natural log of 2 squared, or the cotangent of x over ln of 4. And there's your final answer. Alright, next one. We've got 1/9 arc sine e to the 3x. So let's put all this together. Y prime is 1/9 is just hanging out. It's our constant multiple. The derivative of arc sine is u prime over the square root of 1 minus u squared. So u prime is the derivative of this e to the 3x, which would be e to the 3x times 3 over the square root of 1 minus u, this is once again the e to the 3x squared. Alright, how can we clean this up? We're looking at 3e to the 3x in the numerator. In the denominator, we have 9 times the square root of 1 minus, and whenever you are raising something raised to a power, you multiply those powers, and that would be e to the 6x. You can definitely cancel this 3 and this 9 if you want to. That would make it e to the 3x over 3 root 1 minus e to the 6x. Alright, number 14. Now we have something with a variable raised to a variable. Whenever you see this, you have to do logarithmic differentiation. That basically says you need to take the natural log of both sides to get that power down. If we do that, this becomes natural log of y equals x. I can bring the power down in front, ln of the tan of x. Alright, now that we have it in this form, we no longer have a variable to a variable power. So we can take the derivative of this implicitly. The derivative of the ln of y is 1 over y, but I just took dy dx equals. This becomes a product rule, u, v. So x times the derivative of v, the derivative of a natural log of something is u prime, which happens to be secant squared of x, over u, tan of x, plus v, which is the natural log of the tangent of x, times u prime, which in our case is just 1. Alright, to get rid of this y, we're going to multiply both sides by y. So we get an expression dy dx equals let's try to clear this up just a little bit. Sine squared, let's just see if we can actually, as I said, clear it up. Secant squared is the same thing as 1 over cosine squared of x. And we're dividing this by tangent of x. And tangent of x is sine x over cosine of x. If I'm dividing by tan, it means I'm multiplying by the reciprocal. Which means this cosine will cancel with one of those. So this really becomes x over, in the denominator we're left with cosine of x times the sine of x. Plus, we've still got our ln of tan of x, and this whole thing is still being multiplied by y, which is our original equation, which is tan of x to the x